Residential structural loading for designers and architects. Roof loads, presented by Portland Community College. Today, we'll look at light frame construction, which is typical for building houses in the United States, and the loads it must withstand. Light frame construction consists of repetitive members, like wood rafters or trusses for the roof structure, wood studs for walls, and wood joists for floors. We use a shorthand to describe the combined loads as a certain weight per square foot, called a uniform load. The calculation is load in pounds times 1 square foot equals uniform load in pounds per square foot. Both roofs and floors carry live loads and dead loads. Live loads are temporary, like snow, furniture, and people. Dead loads are permanent, like the weight of building materials. Uniform loads are a combination of live loads and dead loads. Think of uniform load as a weight, like a sandbag sitting on each square foot of roof. It's called a uniform load because the repetitive members and the load they carry are evenly distributed across the roof. Loads start at the roof. Structural repetitive members at the roof, rafters or trusses, transfer horizontal loads to beams or walls. Additional loads occur at the floors, and the repetitive structural members, floor joists, transfer the loads to beams, walls, or columns. All of these loads are eventually transferred to the foundation system. Tributary area. The equation we use to calculate total loads for horizontal surfaces, like roofs and floors, is the uniform load in pounds per square foot times the tributary area in square feet, which equals total uniform load in pounds. For the area, we need both a width and a length. However, these uniform loads can also be expressed as pounds per linear foot, which is how we measure loads on walls and beams. To get this number, we need to identify the tributary width. When we multiply units in pounds per square feet by units in feet, we simplify by deleting the feet from the equation, and the resulting units are in feet. Measuring tributary width. Tributary width is the horizontal measure between support points. This means that the width measured is the same whether it's flat like a floor or sloped like a roof, and the slope can be a little or a lot. The tributary width remains the same. To determine tributary width for roofs, we first need to consider the type of roof structure and how it transfers its loads. The three types of roof structure are trusses, rafters with ridge board, rafters with ridge beam. Both trusses and rafters with ridge board transfer roof loads in the same way, so we'll look at them together. It's important to remember that the ridge board is non-structural and merely provides lateral stabilization to the rafters at their peak. To calculate tributary width for trusses and rafters, which transfer loads to exterior walls, we measure horizontally from the ridge to the edge of the roof. Note that we measure half of the roof width, because half the roof transfers its load to one support wall and the other half transfers its load to the other support wall. We include eaves in this calculation. Later, we'll look at eaves separately. This example has a roof that's 19 feet wide. Half the roof, from ridge to eave, is 9'6" linear feet. The uniform load can be looked up in the building code. If this house is in Oregon, the live load, snow load, would be 25 pounds per square foot. The dead load is 15 pounds per square foot. Remember, live plus dead equals uniform load. For this example, in Oregon, 25 pounds per square foot plus 15 pounds per square foot equals 40 pounds per square foot uniform load. Our uniform load per linear foot will be our uniform load times our tributary width. Our load is 40 pounds per square foot, and our width is 9 foot 6, which equals 380 pounds per linear foot on each supporting wall. Tributary width for rafters with ridge beam. Here's an example of the same house with rafters and a load-bearing ridge beam. Each rafter transfers half of its uniform load to the structurally significant ridge beam, which sits on columns or end walls, and the other half to an exterior wall. Our loads are supported by more elements in this type of structure. First, let's establish tributary width for the load on the beam. Measure horizontally from the beam to halfway to the exterior wall. Note that it's a quarter of the width from outside wall to outside wall. In this case, a quarter of the length equals 4 feet. Measure again on the opposite side of the ridge beam to a point halfway to the exterior wall, and add the two numbers to get the tributary width. Our uniform load per linear foot will be our uniform load times our tributary width. Our load is 40 pounds per square foot, and our width is 8 feet, which equals 320 pounds per linear foot on the beam. Now let's establish tributary width for the load on the walls. Measure horizontally from halfway between the ridge and the wall to the exterior wall. We noticed before that it's a quarter of the width from outside wall to outside wall, and in this case, a quarter of the length equals 4 feet. But what about the eave overhang, the portion of the rafter outside the wall? We need to include it because it rests on the wall as well. So measure horizontally again from the outside wall to the edge of the rafter. Our overhang is 1 foot 6. Add the two numbers together to get the tributary width. 4 feet plus 1 foot 6 is 5 foot 6. Our uniform load per linear foot on the wall will be our uniform load times our tributary width. Our load is the same as before, 40 pounds per square foot, and our width is now 5 foot 6. 40 pounds per square foot times 5 foot 6 is 220 pounds per linear foot on each supporting wall. Let's revisit tributary area before we end our discussion on roofs. Remember, the equation we use to calculate total loads for horizontal surfaces, like roofs and floors, is the uniform load in pounds per square foot times the tributary area in square feet, which equals total uniform load in pounds. For the area, we need both a tributary width and a tributary length. The example with trusses, or rafters with a ridge board, has 2 tributary widths, therefore 2 tributary areas. Each area is 9 foot 6, tributary width, multiplied by the 19 foot length, for a total of 180.5 square feet. Multiply the square feet by the uniform load for a total of 7,220 pounds. This is the load of half the roof that rests on one exterior wall. The total roof load on this small house is 14,440 pounds. This is true for both a truss roof system and for rafters with a ridge board. For the example of the rafters with a ridge beam, there are 3 tributary widths and therefore 3 tributary areas. The ridge beam's tributary width is 1/2 of the total span, or 8 feet. The length of the roof is 19 feet. The tributary area is 104.5 square feet. The ridge load is 6,080 pounds. One wall supports 4,000 180 pounds, and so's the other. The combined load on this small house is, once again, 14,440 pounds. We hope you learned something today, and thanks for watching.